facing a global health crisis. Less than 90 years have passed since antibiotics were first discovered and later utilised. However, it is predicted that in less than 10 years, once again, minor operations, common sicknesses and infections can be fatal. Many individuals with antibiotic resistance has steadily continued to render common antibiotic use ineffective. Many individuals will be exposed to these fatal bacterial infections. The world is headed for a post-antibiotic era in which minor injuries and common sicknesses which have been treatable for decades can once again kill. Sir Fleming recognised the potential negative aspects of using antibiotics indiscriminately, urging patients to only use antibiotics when absolutely necessary, when it is proven they will actually work, and to never use too little or for too short a time. These conditions encourage the resistance of bacteria to antibiotics. The World Health Organization has recently issued a report on the seriousness of antibiotic resistance, a global health crisis. In the report, it notes an example where over 1 million people worldwide are infected with gonorrhea daily, an STI which was once able to be effectively cured using penicillin. However, it has been confirmed in at least 10 countries, including Austria and Australia, that last resort antibiotic treatments have failed. Gonorrhea is now unable to be easily treated in these countries. The more antibiotics dispensed, the more opportunities the bacteria have to mutate and become resistant. Counties Manukau has the highest percentage of antibiotics prescribed. This high community use is of concern, as up to 50% of all antibiotics dispensed are not needed or not prescribed effectively. New Zealand hospitals have had sporadic cases of superbugs such as ESBL or MRSA. However, due to stringent protocols and hygiene regulations, they have helped control the growth of superbugs. However, the per capita consumption of antibiotics in New Zealand, in contrast to most European countries, is growing at 6% per year. Due to the need for new, more costly antibacterial agents and increased hospital stays as a result of this issue, antibacterial resistance poses a significant burden to the health systems of New Zealand and the world. Population densities, migration, and relatively easy world travel means that antibiotic resistance spreads rapidly, making it a global as well as a local issue. How can these bacteria adapt so quickly? The Darwinian model suggests mutations occur in pre-existing genes, which are positively selected by natural selection, favouring those bacteria containing the genes which enable them to better survive in their environment. For example, antibiotic resistance is a favourable gene, which enables the bacteria containing it to better survive and reproduce. When these bacteria are exposed to antibiotics, the susceptible species are supplanted by more resistant strains, so overall proportions of increased resistant strains increase. These resistant strains are able to encode the resistant gene onto transferable plasmids and transposons. This change is rapid due to the extremely short bacterial generation time. For example, in 1941, most strains of Staphylococcus aureus were vulnerable to penicillin. However, by 1944, some displayed resistance. Today, over 95% of Staphylococcus aureus worldwide is resistant to penicillin. Since the development of new antibiotics can take 5 to 10 years, requiring large amounts of money and resources, traditional methods of antibiotic discovery cannot keep up with the evolution of bacteria. Gram-positive bacteria are sensitive to antibiotics, whereas commonly gram-negative bacteria are not affected by antibiotics. This is due to the nature of the bacterial cell wall, with gram-positive bacteria having a thick peptidoglycan layer, which antibiotics are able to penetrate and disintegrate, and gram-negative bacteria having a smaller peptidoglycan layer and a toxic outer membrane, which impedes antibiotic entry. New research has been focusing on gram-negative bacteria. These new antibiotic drugs will focus on the protective outer barrier of gram-negative bacteria. Multi-resistant bacteria are formed by the bacteria's ability to undergo conjugation and horizontal gene transfer, both of which essentially are the bacteria's ability to transfer its own genetic material to bacteria, either of the same or different taxa. When the genes which the donor bacteria donate to the recipient bacteria include antibiotic resistance, both bacteria contain that particular strain of antibiotic resistance. During this transfer, random mutations can occur, which may result in new strains of antibiotic resistance, leading to multi-resistant bacteria. One immediate solution is education in prescribing antibiotics. Taking antibiotics when not necessary and when antibiotics will be ineffective, or failing to complete the full course of antibiotics encourages the evolution of bacteria. Patients' expectations have a significant influence on prescribing, even when their doctor determines that antibiotics are not needed. This can cause some controversy, as many patients paying money for treatment expect some medicine. No one enjoys being ill, and antibiotics are probably one of the most well-known medicines available. I asked about 50 people in my community, and none of them took antibiotics as prescribed or understood how superbugs developed. Education is required in explaining the importance of controlling superbugs, and education of patients to complete the full prescription of antibiotics, and not giving the medicine to other family members or their cat, as one friend of ours did, and not saving the medicine for later illnesses. Many people stop taking the penicillin as soon as they feel better. However, this has not killed all the bacteria and allows the remaining bacteria to mutate to resistant forms in response to the low levels of antibiotic taken. My personal position is that we have become conditioned to expecting quick and easy solutions. When we become unwell, we assume we can be given an immediate remedy. However, for viral infections, antibiotics do not help, and in fact will make us worse, as they destroy beneficial bacteria that our bodies will have to restore, as well as still having to fight off the viral infection. Education is required in explaining the importance of not administering antibiotics properly, and education of patients to complete the full course. We need to take pressure off our doctors and educate society. There are numerous benefits for encouraging awareness about antibiotic resistance. Economic benefits include less deaths, medication, less time off work, and the slowing of the growth of superbugs. Social benefits include a decrease in long-term sicknesses, long hospital stays, bereavements, and allowing time for science to develop new treatments. The benefits are also environmental, where there will be less antibiotic pollution in systems and less antibiotic-resistant bacteria, which may further mutate. In the UK, scientists have discovered bacteria resistant to some of the most powerful antibiotics for the first time in a British river. The scientists have pinpointed the likely original source as a local sewage treatment plant. The researchers believe this shows how widespread antibiotic resistance is in the environment, with sewage treatment plants acting as giant mixing vessels for antibiotic-resistant genes to spread to different microbes. Costs would include those needed for raising awareness, and these would include advertisement, posters, and education in the health sectors. Current research alternatives which can be considered include antibacterial peptides found in animals, which aid in removing bacterial infections, or the inhibition of pathogenicity. Or another option could be found in crowdsourcing, where undergraduate students discover new bacteria around the university, some of which may potentially have antibacterial properties. My idea is that every doctor's surgery, every hospital ward, every healthcare provider, every school should have a poster on the wall targeting, by relevant messages, different groups in society, educating them on the importance of only taking antibiotics when necessary, and if taking antibiotics, then completing the full course once started. A nationwide educational campaign is required. Television, papers, schools, and the workplace. We all need to be involved. Doctors need to be able to say no to unnecessary antibiotic use and offer other medicines to help patients get better faster. Elixirs for flus and colds, patients and parents want something. Pharmacists need to include an information sheet and an explanation with every prescription given out. And the community needs to be educated against expecting a quick fix from their local healthcare provider. And society continue to be educated that viral infections such as flus and colds do not respond to antibiotics. And to complete their full prescription and not save the medicine for later illnesses or share them with other people. This way, we can help prevent a global epidemic of superbugs. In educating society about the need for properly administering antibiotics, the speed of proliferation and imminent onset of complete antibiotic resistance will be slowed, allowing time for science to develop new treatments with which to replace currently prescribed antibiotics. In the last 30 years, no new major types of antibiotics have been developed. I plan a career in the healthcare sector, and when I graduate from med school, I still want to be able to prescribe antibiotics. I don't want this in my home, my nation, my community, my world, and I'm sure you don't either. So let's start now. Change our culture together. Right drug, right dose, right duration needs to be the norm. World leaders are comparing this to threats of terrorism and even global warming. Superbugs. What doesn't kill them makes them stronger. Thank you.
Thank you, Siska.
Thanks, Siska. Very interesting area. Just if doctors aren't sufficiently educated and dish out antibiotics unnecessarily, what chances are of educating the public, do you think?
Well, there's doctors are prescribing, for instance, this antibiotic ear gel thing, and the community, the people, when they get it, they're not continually using it for more than 2 days because it actually makes them deaf. Like, doctors are still prescribing it because it actually gets rid of the infection, but the community isn't using it because they're going deaf. So it's almost a bit of having to deal with these sorts of problems as well,
right?
Like practicality.
You mentioned that there was a relationship between high antibiotic use and smoking.
Smoking?
Yeah, smoking, obesity was one of
on my slide.
Yes. Any further evidence of the connection between those two?
No.
Okay.
Sorry.
That's all right. And just to point, counties Manukau, you said on the slide,
yes,
likely to have, they do have higher antibiotic use.
Yes.
They are, of course, more likely to have illness given socioeconomic profile as well, right?
Yes.
So I'm not sure we can...
No, but they're going to need to use antibiotics more carefully then because they've got these known problems that could result in them being more susceptible to getting antibiotic resistance infections.
The other major presence of antibiotics, of course, is its use in animal farming, chickens.
Yes.
Have you looked at that at all?
I have. I think that Obama just recently has gone and signed a thing that means that it's going to be reduced. That in America, there's like 70 or 80% of antibiotics are used just in like poultry and pigs. It's just strange. Obama has just realised it's not good. It's just making them better and fatter. It's not actually needed. So he's gone and signed something that's going to reduce that. So that's a really good start. So I don't think it's too bad in New Zealand, but yeah.
Thank you. Thanks.
Thank you.